Hi everyone. In this video we are going to figure out how to come up with the equation of the regression line for a set of two sets of data that may or may not have a correlation. So you should have already watched the previous video on correlation and causation, and you've learned a little bit about how to find R, the correlation coefficient, and if not, you might want to go back and watch that video first. So let's start with a question here. We are told that two kids set up a lemonade stand for a fundraiser. They keep track of how many cups Y of lemonade they sell versus the number of times X they are calling out for customers. Here are the figures for the last 4 hours. So we have some data here, and oops, let's see, here. Let's turn this. Let me open up this first. We are also going to graph this, but here we go. Okay, so before we get into the grid, this is our X variable. This is going to be our explanatory variable, which is the number of times the kids call out to customers. Hey, come over here. Come get some lemonade. And Y is the actual number of cups of lemonade that they sell. So this set of ordered pairs here has meaning. And if we take a few minutes and plot these points, you're going to see that they do not actually line up exactly. But for example, this first point, when X is 1, in other words, when they call out one time, they sell 2 cups of lemonade. So that's one situation. And I could go ahead and plot all these points, and this is what it would start to look like. Okay, and I've labeled my axes. My x-axis here is the number of times the explanatory variable versus the y value. I forgot to mark that. Y is the number of cups of lemonade you sell. Okay, so as we can see, clearly this does not form a straight line. And so what we're trying to do is figure out the line of best fit. What is the closest sort of line that we could put on here that would possibly represent these points here? Would it look, something like this, or would it look something like this, or would it maybe look something like this? We're not really sure because these pieces of data are very, very spread out. Okay, so erasing that there. The first thing I want to do is plug this data into my calculator. Now, if you have any trouble with that, you can let me know in class, but you're going to want to go to your data. If you click on data, and you'll notice your list pop up. So in your first list, you're going to type your 4x values, 1, 1, 3, and 5. And in your second list, you're going to type in your y values, 2, 8, 6, and 4. So they should line up. You want to make sure that your 5 is lined up with your 4 because this is one day. This is a day when they, maybe this is days of the week. This is Monday, Tuesday, Wednesday, or Thursday. In other words, they sold lemonade 4 times. And on the first day, they yelled out 1 time and sold 2 cups. On the second day, they yelled out 1 time and sold 8 cups. On the third day. So in other words, n equals 4. We are talking about 4 different samples. Okay. And so when you plug all that into your calculator, you're going to come up with, you're going to want to hit second data, which will bring you to stats. Now, if you scroll down to number 2, that we are now in 2 variable stats, not 1, 2 variable stats. If you want to hit enter, and you'll notice you have your X data and your Y data. Your X data we put in list 1, and you scroll down and make sure that your Y data is over in list 2, and then you're going to want to hit calculate. And you're going to notice a lot of numbers here, but what I'd like you to do is you'll see where n equals 4. And then what I'd like you to do is scroll all the way down almost to the very bottom, and you'll see the letter R. And you know from the previous video how to calculate R, but we're not going to go through that now. We're going to use our calculator, and the R value is minus 0.135. Carried out about that far. Okay, so what does this mean, this minus 0.13? It means that our line is slightly negative, and I would say it's not a terribly strong correlation, but we'll get into the testing of that in the next video. Okay. Okay, so if you recall from the last video, if you reviewed lines, you would remember that we have, all right, we have the formula for the equation of a line was y equals mx plus b, and we that was when everything was in a straight line and we had a constant slope. All points were connected. So m was the slope, and B is that y-intercept, where that point where the line crosses the y-axis. Okay, when we're dealing with a set of data that is random, like this, we're trying to figure out that line of best fit, we have to actually go through some mathematics to find out this slope and this y-intercept. It's not so easy as just counting rise over run, because our points are not in a perfect line. So the first thing I need to tell you is that when you have when we're talking about regression lines, the formula changes a little bit, and I'm not going to get into the specifics of why this is, but we write it as y equals b, which is still your y-intercept, plus ax. So now your intercept is here, and your slope is here. Okay, and so this is like your A, and this stays your B, and this is the intercept and the slope. So we're just changing the form of a line. This is what it looks like when we're talking about regression lines. All right, so we have a few formulas here for finding A and B, because if we know A and B, if we know the slope and the intercept, we can find the equation of this regression line. So here's a couple of formulas for you. So to find A, we need to take the correlation coefficient and multiply it by the standard deviation of y divided by the standard deviation of x. And really where this formula is coming from is what it's doing is it's taking a look at these distances. So the standard deviation, as you remember, has to do with spread. So we're taking a look at the distances, the range of space from these points from each other. Okay, and to find the y-intercept, this point right here where it would cross the y-axis, that is going to equal your, and again, these are approximations, they are lines of best fit, they're not exact lines for every point, the mean value of y minus your slope times the mean value of x, and that gives us our intercept. Okay, so if you go to your calculator and maybe you're still on that same screen, if not, you hit second stat. Remember, you want two variable stats. Get back to your list of data, and you will notice that at the very top after n, get mine on here, after n, you are going to have you're going to have n equals 4 for this problem, n equals 4. You are going to notice that x equals 2.5. That means if you add up all your x's and divide by 4, you're going to, so 2.5 is the average number of times that they called out. Remember, x was the value, the variable of how many times they called out to customers to come get some lemonade. Okay, the standard deviation for the x is right below that, and you'll know that should say 1.91, to carry out too far. And then if you scroll down a little further, you're going to skip over the population standard deviation. We're going to go to the mean value of y, which was our number of lemonades that were sold. Of the 4 days, it averaged out to 5 cups of lemonade sold, with a standard deviation of 2.58. I'm rounding here to the hundredths place. Okay, so and then if you recall from the previous screen, our R value was minus 0.135. We had a negative, slightly negative, very weak correlation. Okay, so let me change colors here, and if we plug in now, if I plug in here, R is minus 0.135 times the standard deviation for Y of 2.58 divided by the standard deviation for X, which is 1.91. Okay, and if you do all that on your calculator, you are going to discover that A equals minus 0.182. So that is the slope. Very flat slope. So now we know we have, and it's slightly negative. So we know we have a, if I go back over here and I had all that data, not very many, like 4 points or something. I can't remember how they went. It's going to be, it's slightly negative, but very, very flat. It's going to look something like that, okay, because it's negative, but it's only 0.18. It's not a very steep slope. Okay, and the next thing we need to do is figure out where's that y-intercept, where's that value. So if we do plug into this equation now, the mean of y is 5 minus a, which is, we just computed up here, it is negative 0.182, and times the mean value of x, which was here at 2.5. Now be careful on your calculator here because order of operations tells us we have to do this multiplication first. If you work that out on your calculator, you should get 5.45. That tells us that the y-intercept is here around the point 0.5.45. Crosses the y-axis right about here. All right. So what's the equation of our line? What's the equation of our line? I'll do that back in yellow now. Based on our our A and our B, and plugging into the formula right here, we end up with y equals our B value of 5.45 plus our slope minus 0.182 times x. Okay, so what that means is if y is our number of cups of lemonade, there's actually a little formula here for predicting the relationship between these two. This is the number of times calling for customers, calling out to customers. So this is the relationship between those two. This is what we call the line of best fit, the line or the regression line. So let me take this line and plot it on our previous screen. Okay, here it is. Now I did a really rough sort of approximation here, but I plotted this. Here we go. This y-axis here, right here, the y-intercept at 5.45. So here's where y is 5. Here's where's y. Here's about 5.0, 5.45. That's the y-intercept. And I just really roughly approximated a very sort of slightly negative, slightly flat line, something like this. Really hard to draw on this screen. But in the end, this is the equation of this line. So as you can see, every point on the line is, every one of these data points is not on the line. In fact, it looks like maybe only one of them even is actually on the line. But it's these distances, if they get minimized, that standard deviation is minimized, this is where the line ends up falling. Okay, so let's use this to make a prediction. Okay, let's say I ask the question, predict how many cups of lemonade, would these kids sell if they call out 8 times for customers. Okay, so the question is, in other words, if you call out 8 times the number 8, if we had this up here, what would be its corresponding number of cups of lemonade that would get sold? All right, so how do we do that? Well, because this is the number of cups, and this is the number of calling out. All right, so if we want to call out 8 times, that's an x variable. We're going to plug it in. So the number of cups is equal to 5.45 minus 0.182 times 8 calls. Okay, so if you plug that into your calculator and do it carefully, you are going to discover that y equals 3.99, or really rounds to about 4 cups, 4 cups of lemonade. So if we call out 8 times, we would sell that. Now that doesn't mean it's going. They will sell exactly 4. It's just a predicted value. And if you look here on our scale, on our graph, if we go out to 8 and up to 4, look at how close. It's right there on, very close on that. Well, actually, it is on the line because that is the equation, that line. So in other words, if we were to call out 8 times, we would sell 4 cups, roughly. Okay, that's an ordered pair. So we can use this line of best fit, or this regression line, to make predictions about things in the future, and that's why they're so useful. We determine some sort of relationship between our x's and our y's, given the data that we have, and through that we can extrapolate what other things might happen in the future. Okay, so in summary, to find a regression line for a set of data, first you have to be given some kind of data. To find the regression line for a set of data, you are going to use your calculator to find the mean of x, the standard deviation, the samples. Remember, S, you're going to use S, not the population standard deviation. So the sample mean, the sample standard deviation for both variables, your x variable and your y variable. And then you're going to have to use your calculator to find that R, the correlation coefficient. And again, it's previous video how you find that value. And once you do that, you're going to just use these 2 formulas right here to help you find the slope and the y-intercept. And when you know the slope and the y-intercept, you just plug them into the equation. And this here is the equation of your line, equation of a line. And that is how you do that. So in the next video, we will learn how to determine whether or not we have enough evidence to support the to conclude that there is in fact a correlation. So go to the next video.